This is where you're really going to understand everything and get it. We're going to be building a library system. And let's see how we can do that within our environment. Typical things you could have in a library system. Let's create a class for book. After creating the class called book, we are going to initialize the class. We're going to define init. Init is to use double underscore, and I use init. This is how we initialize. Self is there by default, and I want to take in two parameters. Give me the title of the book. Hello guys, welcome to my YouTube channel. Today is day 14 of my 15 days of Python series. Well, today we're going to be talking about object-oriented programming. And today I'll try my best to take you through step by step to help you understand how to use object-oriented programming. One thing you must know first is that in previous video when I talked about function, I told you that functions are used to organize your code and make them reusable, so you don't have to write multiple codes that are not modularized. However, object-oriented programming are much more efficient ways that you could organize your code because they are able to cater for more complex use cases, and within it you can also define functions and use it within object-oriented programming. Let's go straight to it and we'll see how to crack that. So in today's video, we'll be understanding OOP, which is object-oriented programming, or OOP for short. We'll be understanding the basic concept, which is talking about classes, objects, attributes, and methods. And we'll also be learning about constructors, that is the init method. I'll be looking at inheritance, polymorphism, and encapsulation. And finally, because this is more practical than just theory, we're not going to be spending much time in the theory, but we'll go more into practical to do some examples, and I'm going to give exercise of your own and we can see how to get on with that. First, what is object-oriented programming? So OOP is a programming paradigm that uses objects and classes to organize code. Like I said before, the main aim of this is to make your code organized and very usable. It focuses on using objects which can contain data and methods to design and build applications. A class is a blueprint for creating objects. And these look like big words, but I'm going to explain them. What a class does is that it defines a set of attributes and methods that created object can use. And the object is an instance of a class. It is created using the class blueprint and can have its own data and behavior. Look at the example I have here. In the example I have here, just the same way I can define a function, here I can define a class. And the class is just setting like a blueprint. Think about a blueprint like an infrastructure for creating an object. I am creating the enablement, or kind of the enabling environment for me to be able to create an object. And if I must say, most of Python infrastructure is built around classes and objects. For instance, if I go to my environment, so for instance, in my environment, I can say x is equal to 2. What happens if I want to see what data type x is? I could just say type of x. If I'm to print this out, I'm going to say print this. When I run this, it shows me that s is of the class int. Int is a class, and this s is equal to 2 has become an instance of the class. In other words, s is equal to 2 has become an object. There's an existing class called int. Int is a class on its own and it has been defined within Python. And when I put s is equal to 2, I am calling that class. I'm creating an instance of the class. I'll give you another example. If I come and I say a is equal to, let me create a list, and I'm just going to put a bunch of whole numbers in the list. If I should print a, it's going to show me that a is of the class list. List is a class within Python. And the list, I'm able to create an instance of the list. By instance, I mean I'm able to leverage the blueprint that has been set within the Python infrastructure. And in the Python infrastructure, they've said that if you have anything that looks like this object is going to be called a list. And anything that looks like 2 is going to be called an integer within the class. And anything that looks like a string is going to be called a string in the class. And when I create a string, I'm calling that class, I'm calling the blueprint, and I'm creating an instance of the class. And so a class, just like I have here, I'm creating the class. After creating the class, I can initialize it using the constructor. In other words, I can initialize the class and say that this class I'm creating is going to take itself, take two arguments. The argument or parameter is name and age. And if I'm going to call this class called dog, I'm going to take name and age, and it's going to be name, and it's going to print out name. And here I'm able to call the class. And when I call the class, I'm just giving a variable here, and I'm going to call dog. Dog, I'm going to take two parameters, body and 5. And when I take the parameters, I'm able to now create an instance. You can see here is creating an object instance of the class. I can create an instance of that class. Within the Python infrastructure, typically if I had created this class myself, let's say I created a class called list, I create an instance of the class dog. And when I create the instance of the class, I can actually call the instance, I call dog, and I impute the parameters within it. And in such a way, I'm able to get the attribute of my class. So you could create a class. Before we go to attributes, you could create a class, and within that class, you can create an instance of the class, and the instance of the class is called an object. This is the class. I've created a class, and I can call the class. I do two things. I create the class, I initialize the class. The moment I create a class and I initialize, I can actually call an instance, create an instance of the class. To take it a bit further, attributes, they are variables that belong to a class or an object. They can be class attributes shared among all instances or instance attributes specific to an instance. And the method, they are functions defined inside a class that describe the behavior of a class. Let me bring it down. Attributes are actually giving you the different properties of the class. For instance, if I create a dog, what are the normal properties of the dog? The dog has a name, the dog has an age, the dog might have a breed. I'm creating the properties of the dog. These are the attributes, what defines the dog. The method is the functions of the dog. What does a dog do? A dog sleeps, a dog barks, a dog eats, a dog does a couple of actions. The different actions the dog performs, you could call that a method. Within attributes, just go over it again, the attribute helps you to understand the properties, while the method helps you to understand the actions. If I should go back to the example I have here, I have my class. My class is the list, and I just created an instance of the list called the object. What are the typical methods of a list? Within Python, a list has a method called, now the action, it has a method called the append. I could say, calling my list, which is A, I just created dot. When I put dot, I will see all of the different methods of the list. In other words, I could see all of the different actions I can do with the list. What are the actions you could perform when you create a list? I could use this simple one called the append. And the append, I could say I want to append 5. So let me print the list before the append and after the append. So I can now print this. I'm going to say print A. Aside, I'll say A append. And I'm going to append to A. And I'm going to say print A again. Let me take this out. If I run this, you could see that I just have my list. However, when I append to A and I do print A again, you're going to see that I've appended 5. 5 gets appended. So append is a method within the class list. So list is a class, and I created an instance of the class called A is equal to this list, and I can call the method. So the method are the actions that you can actually execute within your class. And the attribute is just listing the different properties of that class. And it depends on what I'm creating. The init method, what is the init method? I made reference to it just now. The init method, also known as the constructor, is called when an object is created. What it does is to initialize the object attribute. Here I have a car I've created as the class. And in my car, I put all of the attributes of the car. The car has a make, it has a model, it has a year, and I put all of these as parameters that the class is going to take in. So the class will take in these parameters when processing this. And I define that in the constructor. When I'm done with that, I can now create my method. And what is my method? What my method is doing is to define a method that says display info. In other words, using this class, if for any reason I create an instance of the class, which I have here. I call it my class, my car. I've created an instance of that class using car and putting in all the parameters. I can actually print my car.displayInfo. The display info is a method that I've created. A method is what it does. And when I put the output, it can actually return all of this instruction that I've put in here. Using a formatted string, I'm going to print out the year, the make, and the model. This is actually a very, very key use case of in the init method. So to go over this again, I create my class. After creating the class, I initialize the class. After initializing the class, I can now initialize my method. Give it a method, and the method could be anything. It's just saying what action can the class take. And when you create an instance of the class, meaning you create an object, you can actually go ahead to use the method. What is inheritance? Inheritance allows a class to inherit attributes and methods from another class. For instance, I have the first class that I've created is animals, and I've initialized the class. And the initialization I give is very straightforward. It's just to say the self.name is going to be name. You return the name that is imputed in this parameter. And I'm going to put in a method, an action. What does the animal do? The animal returns animal makes a sound. I'm going to put speak. Speak is going to be the method I'm creating. The animal makes a sound. That is what is returned when I use the method speak. I want to create another class for cat. Because cat is an animal, I don't want to go ahead and recreate all of the properties that I've created for animals already. Cat naturally would have the same properties with the animals. The only difference most times might be the method. That is the action that the cat takes. The cat meows while the dog barks. In most cases, the initialization, the init are all the same. That is, the attributes are all the same for all animals. I can come here and say, instead of creating a new one, I can just come and inherit the properties I have already created for animals. And I can come and say cat, adopt the animal properties, and here I can now ascribe a new set of method for my cat. And I'll put speak, and it returns the self.name says meow. So what it means is that the self is just whatever object they are using, and it's going to select the particular object. It's going to put the name of the object that you selected here. It says that it meows when you are calling the class cat. An example of it is this. So I'm going to create an instance of the object called cat. And when I do that, it takes all of these attributes of the cat, talking about the name, and returns the name of it. And I don't need to specify all of these here again. It just takes the name, inherits it from the parent, which is animal. And I can come and print my cat.speak. What it outputs is Whisker says meow, because I've given the self.name, which is Whiskers, while creating an instance of the object. And I can just do .speak. You don't need to put self here again because self happens internally. And I could just leave it and open parentheses, and this brings out this result. Polymorphism allows objects of different classes to be treated as objects of a common superclass. And superclass is actually talking about the parent class. It enables a single function to operate on objects of different types. So in polymorphism, if you create two methods for two different classes and you want to bring them all into one single method, you can do that. Poly just meaning many. You can bring them all into a single method. So let's say we created two different methods for cat and for the class cat, and created another one for the class dog. There's different methods for their expressions. The cat meows and the dog barks. If you have these two methods, you can actually bring them all into one and create a single method for calling these different methods, these different behaviors of these animals. And you can all bring them into one umbrella to say animal.speak. And when you print that, it could print body speaks wolf, because this is the parameter you imputed here. And you can have Whisker says meow, because this is the parameters that you've included here. So it's possible to bring different methods into one umbrella and have them as a single unit. What is encapsulation? Encapsulation restricts access to certain components of an object. What it does is to protect the internal state and prevent unauthorized access It is implemented using access modifiers. You have the public, protected, and private. For the previous example I've been creating, you could see that when I was initializing the class, under self, I didn't have any kind of underscore. I just put self. This first one, the self.owner. This is public because no underscore was used while defining the self. But in the balance, let's say I'm doing an account, bank account. This could be used within very, very protected systems of a bank accounting system. And I want to create a class for the bank account. And the bank account is going to have a method, activities, deposits, withdrawal, balance, and all of that. I want to protect the balance and I want to make it private. To make it private, you just use self.double_balance. And the moment you do that, the balance becomes private. If you want it to be only accessible within the class and its subclass, to do that is to use a single underscore. But to make it totally private is going to be a double underscore. And encapsulation just helps you to do all of this protection, security within the class that you're creating. And this comes in handy when you're creating some kind of systems, complicated systems that will require a level of protection and safety. Someone may be asking, what is the actual use case of object-oriented programming? This thing is just neither here nor there. Where can I use it? Where is it being used? Well, the first use case is in game development. In game development, you could define classes for player, enemy, weapon to manage different components. So the OOP helps to create modular game objects that can interact with each other while being defined in separate and manageable code blocks. It's also used, just like we've defined here, in inventory management system. You create classes for product, order, and customer so they can manage various aspects of the inventory system. And in banking system, just like I've given an example, it could be used. There are so many use cases, and if you're a data engineer, you use objects and classes to create different transformation work that you're doing, defining the several functions, the several cleaning that your organization apply, and you use all of that to make your code reusable, and so you don't have to go back and forth in what you're doing. This is where you're really going to understand everything and get it. We're going to be building a library system, and let's see how we can do that within our environment. If you've not, please go ahead and create the day 14 and create the example 1. I'm just going to clear this now. In the library system, what are the typical things you could have in a library system? Let's create a class for book. After creating the class called book, we are going to initialize the class, and that is to create the constructor. We're going to define init. Init is to use double underscore, and I use init. This is how we initialize. Self is there by default, and I want to take in two parameters. Give me the title of the book, and you give me the author of the book. For the author is going to be the self. The self is actually the object that you provide. Self.title is equal to title. Self.author is equal to author. And I'm going to be creating a boolean just to tell us whether the book is available or not. When you come to borrow the book, we're going to check if this is true or false. So I'm going to call this self.available. I'll set it to true because the assumption is that nobody has borrowed any book. Okay, let's see if you get this. I've created a class called book, and I've initialized the book, created the attributes of the book. The book has a title, it has an author. What are the activities that can go on with this book? What are the behaviors of the book? What actions will be taken on this book? The first is borrow, because I'm creating a library system. Now I'm going to create the method borrow. You can borrow a book. I wanted to check self-available. If self-available, that is, if this is true, then you set self.available to false, because you are now borrowing the book, and if you're borrowing the book, this should be false. The book is out of stock. And when you're done, you return book borrowed successfully. Else, what should happen? If it's not false, if it's not true, then I'm going to tell you that the book is currently unavailable. This is throwing an error because on the borrow, I need to have self here. Yeah. All right, let's go on. What other action can happen with the book? Another action that can happen with the book is the return. When you borrow, you return. I'm going to define the return. Self self.available is true. The moment you return it, this is set to true. And after that, I'm going to return book returned successfully. Let me call this return book. Yeah, because return is a reserved word in Python. Okay, let's try. I'm going to say book. Let's try to borrow a book. I'll create an instance of my class. I create an instance. I say book. What are the book? 1984. That's the title. Who is the author? George Orwell. So let me borrow this book. I'm going to take an action on the book, and the action I'm going to take would be book.borrow. When I borrow that, I'm going to run this. When I run that, it's going to return book borrow successfully. If I'm to return the book, and I say book.return book, I'm going to take this out and I print this. It tells me book returned successfully. So you could use this to actually build a library system, and building a library system, of course, is more complicated and there's a lot that goes in, but it gives you like the framework on how these things can be applied and how you can use classes to actually implement something like this. Second example, we could build an employee management system. Similar to that, I'm going to go to my environment. Let me create a new one and call this example 2. In my example 2, I'll create a class called employee. Class employee, and I do this, initialize it, and I'll take on other parameters. I want you to provide me your name, your position within the organization. Oh, this is spelled wrongly. And your salary. Hopefully you do that. And when I'm done with this, I'm going to initialize and set up all of the properties or attributes. Self.name equal to name. Self.position is equal to position. Self.salary is equal to salary. And after that, I'm going to have a method. What we want in our organization is to set up a method for promote. We want to perform an action for promote. And the self is constant, but I'm going to take on other parameters. The new position we want this employee to be in. Self.position will become the new position that will provide. And we return, I'm just going to use an F string here. What it should return for me is the name of the employee, and I'm going to say has been promoted to the new position. All right, let's try this. I'm going to give the name, and I'm going to just call this employee. Let's create an instance of my class. We'll use employee. I require 2 parameters, or 3 rather. I'll put a name, David, Ezekiel, a data engineer, and my salary. Let me just put 100. Just put 100,000, and I'm gonna print employee. That's now I'm going to promote. Put in the method. What's the new position? I'm gonna call. Say I want to promote David to senior data engineer. And when I do that and I print, you're gonna see what will happen. Let me print this. David Ezekiel has been promoted to senior data engineer, and this is how you could work with this and build an employee system and just play around it and see what you could have. Now, for your exercise, I would like you to write a Python script that defines a class rectangle with attribute length and width and methods to calculate the area of the perimeter. So you're going to have the class, the rectangle, and you're going to set like the method, one for the area and another for perimeter. And you create an object of the class, like to call it, and you create an instance and use it to calculate and print the area and perimeter. This is quite going to be easy if you've understood all we've been doing. Try it on your own and let me know, and I'm going to be providing a solution to this in the next slide. I'm going to create exercise 1. In this exercise, I'm going to create the class, class rectangle. All right, just to define it is going to be initialize self. I'm going to be taking 2 parameters, the length. There's an n missing. Yeah, and the width. I'm going to say self.length is going to be length. Self.width Be the width. I'm going to set a method for calculating the area, and I'm going to call this area self, and what I'm going to return is self.length. Of course, area is length times width. Oh, sorry, length times width. Set up the next parameter for the perimeter. Call this perimeter self. You return 2 times self.length plus self.width. I've created a variable where I'm going to set an instance of my class rectangle, and I've provided my length and my width, and afterwards I'm going to print the area. The area is simply me just calling the method, and similar to this, I'm going to call the method parameter. When I'm done, I'm going to run this, and it gives me the area as 15 and the perimeter as the 16. This is quite interesting because you can do a more complicated thing using this. And like I said before, within Python, you have the functions, inbuilt functions in Python you can use. So as you have functions are more generic, is not subject to any kind of class, is not restricted by class. Most of the functions can be used across any class. But when it comes to methods, methods are restricted to the classes, the object that you're actually using. Just like we have the list as a class within Python, there are methods you can use for list, and there are methods you can use for list. And within Python, you have inbuilt functions and inbuilt lists, and sometimes it could be very, very overwhelming when you try to understand what is a method, what can I use, what functions can I use, how do I find them. To do that, I've put up like a spreadsheet that gives you all of the different methods and functions you have within Python. The different functions, just the very, very basic functions you have within Python. You also have the methods, the different methods that you could use. I've kind of segmented them into list methods, string methods, dictionary methods, set methods, because methods are restricted within the particular class. And these are different classes. Dictionary is a class, set is a class, tuple is a class, and these are all inbuilt in Python. You can download these and always make reference to them. Please like and share and subscribe so that others can have access to these, and also to encourage me to do more of these videos. And I'm gonna see you in my next video. Thanks for watching. Bye for now.